Hi everyone, this is Sharon Rozovsky from the Department of Chemistry and Biochemistry at the University of Delaware. I grew up in Tel Aviv, which is a very large city right by the ocean in Israel. I got my undergraduate education at Tel Aviv University, and I came to the United States to obtain my PhD in New York City at Columbia University. I studied with Anne McDermott, and I was absolutely fascinated with the question of why do protein needs to move in order to accelerate chemical reactions? Why do protein change their structure in order to accelerate the rate of chemical reactions? And in my PhD, I used a variety of different techniques. I studied the motion of the proteins by NMR, nuclear magnetic resonance. I used fluorescence studies. I crystallized proteins with a substrate. I had the chance to build my own NMR probe. I overlapped a little with computational chemistry. It was really exciting and wonderful time. So when I graduated, I thought that what I want to do is expand and learn a little more about the function of proteins in different environments. And so during my postdoc, in University of California, Berkeley, I studied biological membranes. I looked at what are the properties of biological membranes and how they influence the structure and the function of proteins that are embedded inside, that is, membrane proteins. So during my postdoc, I did quite a bit of single molecule imaging. I tracked how membrane proteins diffuse inside the membrane. I looked at how the properties of the membrane change when there's different lipids and different proteins inside. And I really enjoyed this um, bigger picture of thinking about how the environment of protein change the way that they can interact with one another and assemble together to form machineries. So when I started my own research group here at the University of Delaware in 2008, I brought together those two different topics that fascinated me the most: the structure of proteins and why they need to have this conformational mobility to perform their function, and biological membranes. And so my group works on membrane proteins. Particularly, we look at membrane proteins that have selenium inside. The group of proteins that have selenium inside are all enzymes, and they're involved in protecting the cell against damage. That is, they protect the cells against chemicals that tend to react with cellular components and damage them. So they're very important in processes such as aging, preventing cancer, preventing neurodegenerative diseases, responding to stress, and it also turned out that they're very, very important in the progression of COVID-19. So in my group here at the University of Delaware, we use structural tools, we use biochemical tools, we have a lot of biological mass spectrometry. I really enjoy combining all those tools together, but also to think about what are the advantages that selenium endows in proteins? Why does it make them better enzymes? Why does it respond better to cellular stress? And if you want to learn some more, you could follow up by looking at our group poster. So welcome to the University of Delaware, and I hope that you enjoyed this recruitment day.